Hi, so we are moving on to our Unit 4, which is all on bonding, and there will be two chapters in Unit 4. Chapter 7, we talk about ionic and metallic bonding, and Chapter 8 is devoted to covalent bonding. So this graphic is from the beginning of the year, and I just am bringing it back so that we kind of understand where we've been and where we're going. So at the beginning of the year, we talked about matter in general, and we spent some time talking about mixtures, the difference between homogeneous mixtures and heterogeneous mixtures. And for the most part, up until now, we have been focusing on the elements. So we did a whole chapter on the structure of atoms, looking specifically at the nucleus. Then we did a whole chapter looking at electrons, and then the periodic table, the different types of elements that there are. Now what we're doing is we're focusing over here on compounds. And compounds, we know, are when we have multiple atoms bonded together. And bonding is a general term. We're going to learn that there's many different types of bonds, but just in general, why do bonds form? So we're going to look into how they form, but this is in general why. And atoms bond because they become more stable. That is a running theme throughout all of chemistry, is that matter wants to be as stable as possible. And matter or atoms are more stable when they have a full outer energy level. And they can donate electrons, so that means give them up, receive. They can donate electrons, they can receive electrons, or they can share electrons. Specifically, it's only the valence electrons that are involved. And when an atom shares or receives or donates valence electrons, it allows it to achieve that noble gas configuration. And this is called the Octet Rule. The Octet Rule states that atoms will try and achieve 8 electrons in the outermost energy level or the outermost shell. Why 8? Because the outermost energy level of almost every element contains s and p sublevels. So that means 1 s orbital and 3 p orbitals. Each orbital can hold 2 electrons. That's how we get 8. That almost every element, except for the smallest elements that only have 1 energy level, most elements will be most stable when they have 8 valence electrons, because that means their full outermost energy level. Their outermost energy level is full. So there are different types of bonds, and we are going to look at ionic and metallic in this chapter, and we're going to look at covalent in the next chapter. But just to give you an idea about where we're going to fill out this table to help us understand the relationship between these 3 different types of bonds. So what's going on to the electrons in an ionic bond? Well, the electrons are transferred. They're given, we will learn, from the metal to the non-metal. Whereas in a covalent bond, those electrons are shared. In a metallic bond, the electrons do something a little bit different. They are delocalized in what we call an electron sea. all that really means, and we will go into this in a lot more detail later on in the chapter, is that the electrons are able to sort of orbit one metal atom and then jump to another and jump to another and jump to another and jump to another. And that's how the electrons are organized in a metal. So what type of elements make this bond? Well, in an ionic compound, it is a metal and a nonmetal. In a covalent molecule or covalent compound, it's only two nonmetals. And in a metallic bond, it's between metals. So you can see that if it's all metals, it's metallic. If it's all nonmetals, it's covalent. If it's one of each, it's ionic. What is the state of matter? So the state, like what is an ionic compound? Well, that would be in what we would call a crystalline solid. Those ionic compounds are all solids at room temperature, and crystalline just means that the ions are arranged in a geometric repeating pattern. They're not randomly organized. In a covalent compound, we would call them molecules, and they are solids, liquids, or gases at room temperature. They're very varied in their state of matter. Covalent compounds are very varied, whereas metallic compounds are metals. They're all solid at room temperature, with the exception of mercury. Mercury is a liquid at room temperature. Conductivity. So this is, do they conduct electricity? And we know one of these for sure. We should remember that metals do conduct electricity. That was one of the properties that we learned about metals. Covalent compounds do not conduct electricity. Ionic compounds do, but only under special circumstances. They do when they are either liquid or dissolved in water. Melting point. How does the melting point of these compare? Ionic compounds are very high. Metallic, generally high. It's less definite. And covalent compounds are generally low. That doesn't mean that there aren't exceptions. There are, of course, exceptions. But for the most part, covalent compounds have very low melting points. That's why many of them are gases or liquids at room temperature. So the big examples of these, when we think of ionic compounds, of course, the biggest example that we talk about all the time is salt, NaCl, or sodium chloride, because you use that, you've seen that, you've experienced that. So that's the one that we use often to try and think about when we think about ionic compounds. Similarly, with covalent compounds, we use the most common, water. You know what that looks like. That is a covalent compound. And anytime that you're talking about a metal, you know, you could think of iron or copper or gold, any of those metals that you have had experience with. So this is just a great overview of what we're going to be talking about in the next 2 chapters. And we will spend lots of time going into much more detail about all these aspects.